Hello, welcome to Unit 1, Section 3 of our Algebra course hosted by Rhythm Tutoring. Today we will be learning about factoring, GCF, and LCM. Let's start. So what are factors? Factors are terms or numbers that are multiplied to get a product. For example, we have 6 times 7, which equals 42. 6 and 7 are factors because when they're multiplied, they result in a product of 42. So this is the product, and these are the factors. Factors are also divide a number completely without any remainder. For example, 42 divided by 6 is equal to 7, and it has no remainder. So therefore, 6 and 7 are both factors of 42. A number can also have many factors. For example, factors of 12 are 1, 2, 3, 4, 6, and 12. So 12, when we divide 12 by 1, it equals 12. 12 divided by 2 is 6. 12 divided by 3 is 4. 12 divided by 4 is 3, and so on. And check. So is 7 a factor of 42? So if we divide 42 by 7, we get a result of 6 without any remainder, which means that 7 is a factor of 42. So then is 7 a factor of 21? So if you divide 21 divided by 7, it equals 3 without any remainder. Therefore, 7 is a factor of 21. Methods of factoring. So list out factors, test out numbers that work as a factor and list them. So for example, here saying you should list out all the factors that are a result of this 16 number. So you can see that 1, 2, 4, 8, 16 are all the factors of 16. So while you can list out factors for this, what if the number was 98? Then listing factors is harder. So there's an easier option, prime factorization. So prime factorization is the listing of all prime factors of a number. A prime number is a number that can be multiplied by itself and 1. So that means that it cannot be multiplied by any other number other than 1 in itself. So for example, 17. The only factors of 17 are 17 and 1. Therefore, 17 is a prime number. Let's check. Is 19 a prime number? So we can see that there are no other factors other than 19 and 1. So 19 is a prime number. How about 21? 21 is not a prime number because you can multiply 7 and 3 to get 21, and 1 and 21 to get 21. Therefore, it is not a prime number. So here is prime factorization. You can prime factorize by making a factor tree. So here you can see that 48, 8, and 6 are factors of 48. Then we can keep splitting them apart. So 8, 4, and 2 are factors of 8, and 2 and 2 are factors of 4. And the other side, 6 is a factor of 48, 2 and 3 are factors of 6. So once you've done that, you'll see that the bottom numbers cannot be factorized into more factors. So these are the remaining factors of 48, 2, 2, 2, 2, and 3. And they all equal 48 when you multiply. So now we'll be learning about greatest common factor, GCF. So what is a common factor? When 2 or more numbers share the same factor, then you can see that they are common factors. So for example, 12 and 8. If you list out all of the factors of 12 and 8, you can see that 1, 2, and 4 are all part of both numbers, are both factors of both numbers. So we can say that 12 and 8 will have common factors of 1, 2, and 4. But the greatest common factor is the biggest common factor that the numbers share. So we must look at these numbers and see which one is the greatest. So here, in this case, out of 1, 2, and 4, 4 is the greatest common factor. So therefore, 4 is the greatest common factor of 12 and 8. Okay, so GCF methods. So if you list out all the factors in the numbers, you can find the common factor and choose the biggest common factor. So that's one option that you can do by listing out all the factors like before. Here, we list out all the factors and see the common factors that coexist in both numbers, or you can prime factorize both of them. So if you prime factorize, you can choose the same common prime number factors that both the numbers have and multiply them together. So here, for example, 150 and 225, 2 times 3 times 5 times 5 is equal to 150, and 225 is 3 times 3 times 5 times 5. And these are numbers that are result from the tree. So 5, 2, 3, and 5, and then 5, 5, 3, and 3. And you can see that here, they both share prime common factors of 3, 5, and 5. So if you multiply them together, 3 times 5 times 5 equals 75, and therefore 75 is the greatest common factor. This works in any case too, because when you make them into, when you prime factorize both numbers, you can see that the lowest numbers, you can find the ones that are common multiples, common factors, I mean, and multiply them together to get the GCF. So what are multiples? Multiples are terms that we can get when we multiply a number by another number. For example, the multiples of 2 are 2, 4, 6, 8, 10, and so on. So this is these are just multiplying 2 times 1 equals 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and so on. And so these are multiples, which means that you can multiply this number by any other number, and that means the result is the multiple of that original number. So a number can have infinite or endless number of multiples, but for now we will focus on the first few multiples of the number. This is because we'll be finding the lowest common multiple, which is the LCM. So check. This is the 5 first multiples of 3. So the first 5 multiples of 3 are 3, which is 3 times 1, 3 times 2 is 6, then 3 times 3 is 9, and then 3 times 4 is 12, and 3 times 5 is 15. So those are the first 5 multiples of 3. So how about 5? 5, why don't you try it out? And you can see. So just multiply 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 5 times 5 is 25. So those are the first 5 multiples of 5. Okay, so the lowest common multiple, LCM. So what is a common multiple? When we multiply 2 or more numbers, they share the same multiple. So the LCM is the smallest multiple that 2 numbers share. For example, for 3 and 4, when we list out all the common multiples, we can see that when we list out all the multiples, we can see that 12, they both share 12 as a multiple and 24 as a multiple. So therefore, 12 and 24 all are the common multiples in both numbers. However, we want to find the lowest common multiple. So you can see that 12 is less than 24. Therefore, 12 is the LCM of both 3 and 4. So this is just finding the lowest common multiple in both numbers that both numbers share, but is the least number that you can get. So LCM methods. If you list out all the multiples in the numbers, you can find their common multiples and choose the smallest common multiple. So this is what we've done before, listing them out like this. So here we have the multiples of 3 and 4. That's what you can do, and then you can find the common multiples in both numbers. However, if you have larger numbers that are more complex, you can use prime factorization. If you prime factorize, you can choose the multiples with the most number of appearances in each number. So 42 and 8, if you prime factorize both of them, you get 2, 3, 7. You can see that this is these are 3 and 7, and then 2, 2, and 2. So 42 and 8 both have prime common factors of 2, but 8 has 3 of those 2s, right? So only 42 only has 1 of these 2. So you would take the 3 2s to multiply. So instead, since 2 is the greatest in this part, you would not use this 2. You would use these 2s. So 2 times 2 times 2 times 3, because there's only one appearance of 3, so you would use 3, and 7. That you would get 168. So therefore, the lowest common multiple of 42 and 8 is 168, because when you see the reason we only use these 2's are because we're finding the most appearances of that number. So 2, there's 3 2's in 8. However, only 1 2 we can find in 42. So we will use 8's 2's instead of 42's 2's. So 2, and then, however, if there's only one appearance of one number, we will use that because that's the only one there is. So therefore, we use 3 times 7 times 2 times 2 times 2 is 168. Practice. So why don't you go ahead and try these out? You can pause the video and yeah. Okay. So hopefully you're done. Well, let's move on. Solutions. So these are the solutions of the problems before. If you want to check, you can check. Yeah. All right. So thank you for tuning in. Make sure to come by for section 1.4 of our algebra course. And yeah, bye.